let's learn how to reverse a linked list. Given the head of a singly linked list, reverse the list and return the reversed list. So this is the input, this is the expected output, and let's get to it. So this is the kind of question that's probably not going to be asked by itself in an interview. This is more of like a primitive type question where that gets you used to a particular sub part of algorithms. So for example, something like checking if a linked list is a palindrome, which is another problem on this study guide, that would, I think, be fair game for an interview, and that involves reversing part of the linked list. But this question is just doing the whole thing and just making sure you know how to do it. So yeah. So first, let's check for an edge case because we've got this pointer input. So if head return 0. So let's talk about like 0. Okay, so sometimes you'll see null. That's like a macro that exists also in C as well. And then in C++, you'll see this other keyword, null pointer. And basically both of those are just 0. These are equivalent, so they're interchangeable. And it's actually, even the maker of C++ himself will just use a 0 quite a lot. It makes no difference computationally. The only difference is, comments, because variable names are comments. So, keep that in mind. Sometimes it matters, sometimes it doesn't. I have at one of my past jobs, it was important enough where there was a few different pound defines for 0, and actually did have, it mattered which one we chose, just for the sake of being extremely, extremely clear. It was it was a critical piece of software. So comment and little esoteric things like that, they did matter, not for correctness, but just for the sake of making sure absolutely crystal clear, everybody could tell easily what it was doing. Anyway, so to reverse a linked list, we're going to need 3 pointers, basically. So let's make those to list node. We're going to have a pointer for the previous item, and that's going to initialize to 0 or null, because, so for example, this first item, its next pointer we want to be nothing. So current. And that's going to be, we're going to start that at the head, and then we're going to have the next pointer. And that is going to be head.next. That's just how they initialize. Actually, while I'm thinking about it, it's better to talk about runtimes ahead of time. So what is our target runtime going to be? Well, we want to potentially reverse every next pointer in the linked list. So there's no way to get less than linear runtime. That is our absolute minimum bound, and indeed that's what we're going to achieve. Then as far as space complexity, well, if we're doing it one at a time, then we can get away with, say, just maybe these 3 or 4 pointers, and then that's a constant number, and then that's not going to change. So we have constant space complexity. Now, for example, if you were to do some studying of parallelized algorithms, sometimes you'll see linked lists pretty much implemented with arrays. So you'd have 2 arrays. One is the list of values, and one is the list of next pointers. You could get away with a logarithmic span in that case. But here we're given literally a literal linked list with pointers and such. So you only have access to one thing at a time, starting from the head. So you can't parallelize that. So it's going to be linear runtime on that. Yeah, so let's start our loop. So while we have a next pointer, so while next. While that's not null, while this is not null, we're going to do stuff. So what do we do? First thing we need to do is save off our previous pointer, I think. So actually, no, first what do? We reverse our current one. So current.next equals previous. and now we inch along these 3 pointers. So we've updated our next pointer, and now we're gonna inch along these starting from the back. So for example, you can't say increment this first and then this and then this, because then you lose some things and then become detached. You push this forward, and then the previous pointer forward, and then the current pointer forward, and then the next pointer you push forward. So previous equals current, current equals next, and then next equals next. It's next. So and next. And then lastly, this is gonna miss the very final next pointer. So you do want to update that again. So it's just this line all over again. So current next equals the previous one. And then you'd return current. Because the current one should end at this. The next would be null. So I think this is it. Yeah, so we talked about runtime. So it's linear time, constant space. O of n time and O of 1 space. We already talked about y. So let's do an example. I'm just going to do this example, I suppose. All right, so head is not null. That's an edge case. So then we start with this previous pointer. So I'm gonna write these out so we know what they are. And then C. Okay. So on each of these, let's say this first space below it is the value, and the space after that is what it's pointing to next. So currently, previous is at null. So its value is null, its next is null. It's null. This doesn't have anything. The current pointer is starting at the head, so that's 1. So the value is 1, and its current next is 2. And then the next pointer is pointed at 2, and its next pointer is 3. So that's what we're at currently. All right, so initialized to null. So that's not a value. That's like literally a null pointer. So while we have a next is not null. So we're going to do a loop. Current next is P. So current next is going to be the previous. So it's going to be null. I'm going to do /0 for null. And then the previous pointer, we change it to current. So that's 1, meaning that its current pointer is now null. The current, we update to next. So that's 2 and 3. 2 and 3. And then the next is going to point to 3, where its next pointer is 4. 3 and 4. And then we repeat the loop. So the current pointer, the current next, so this one, it's 3, goes to, actually, I should probably write out the previous one is going to be the sign that it's correct. So just keep an eye on this. And as long as it's like this is the one right before this, then that should be okay. Yeah. Okay. So we're at the next iteration of the loop. So the previous pointer 1 and 0, current, we're going to update this to be the previous. So its next pointer is now to 1. And then we're going to inch up the pointer. So previous becomes current. So instead of 1 and 0, it's going to be 2 and 1. Current goes to 3 and 4, 3 and 4. Next goes to 4 and 5. Next iteration, this, we're going to update it to the previous. So it's going to point to 2. Previous, and then we're going to inch them along. So 3 and 2. This is going to go to 4 and 5. And this is going to go to 5 and null. 5 and null. And null. Let's see. So while next, we do have, this is still not null. So let's continue. Next iteration, this current pointer, we're going to update to the previous one. So that's going to go to 3. And then we're going to inch them along. So 3 and 2, that's going to become 4 and 3. this is going to become 5 and null. 5 and null. And then this is just going to become null. And then, so this is no longer null, so we're going to break it. Oh, sorry, this is null now, so we're going to break out of the loop. What do? We have to update the current pointer one last time. So current next becomes previous. So this becomes 4. So that's what we want. We want that to point there. So we do need that last update there. And then we return the answer. So 5 and 4. Yeah, I don't have the whole linked list typed out, but hopefully that convinces you. I'll leave that. Let's give it a run for syntax errors. Alrighty, submit. And we're done with that one. Thanks.